have to remember to ask.
Yes.
Okay, so I'm passing around the text. Ooh, wow, that was close. Passing around the textbook that Meg and Marnie are currently using. This is the class that I've never taught and hope to never teach, to be honest with you. This class aligns with Tech 2. So if you're teaching Tech 2, you can add quite a bit of GD&T to that class in order to satisfy our requirement here. So what I'm going to run through really quickly is Meg. This is Meg Leatherberry, and this is Marnie Tobin. And they are the two that swap off teaching this class. Marnie is currently teaching it this semester. Meg has taught it quite a few times before that. Just so you know, this is a required course for anyone who is taking mechanical engineering technology, who is taking manufacturing engineering technology, or design engineering technology. So it's a required course for all three of those majors. And I don't believe, no, engineering is not doing this one, electronics engineering. So those are the three that are required to take this class. So basically what this class is an advanced dimensioning class. So what I wanted to go through is everyone here was here last week when I went over Canvas. This is not completed as of yet, but will be over the summer. So again, what Meg has agreed to do is provide you all for teaching resources. Okay. Thank you. So inside of here, under the modules, you can open up her PowerPoint presentations. Inside of Canvas, it has a program that allows you to go through each of the PowerPoints. So this is an in-class exercise that she goes through with them to have them, to remind them how to just dimension correctly. If I go back to the modules, and we will be building this as we move along. This is just kind of giving you an idea of what is available out there. So this one is where she's really getting into the GD&T symbols. And then one of their assignments in that course is, of course, to right here. Identify those symbols. So again, we'll be building this for you, but just to know these resources will be available to you.
Those same symbols are on the state skills test.
Are they? Great. So
I'm not supposed to know that.
Know what?
I don't know.
okay. So and then I mean she can address this a whole lot better than I, but using the feature control frame and how to read the feature control frames and so on and so forth. So you'll have access to her assignments and her quizzes. Just so you know, what I gave to Tom already has this. She's also put in there her final and her midterm. So you can give the exact final and midterm exam that she is giving up here when she teaches the course.
I really don't like that test.
Yeah.
I really hate that test.
Do your students like that test?
Oh, they hate it.
This is not one of the most liked classes.
Football players cry on that test.
Yeah.
Ooh. Now, then we would be giving two finals. We'd be giving this final, and we'd be also giving the state final.
Again, it's up to you how you set up your course.
I do, because the state final, the state skills test doesn't really get into depth whether we need to know up here. It kind of skips around the surface. This way I know, because they can guess the state.
So use this as your study test for the
That's
state
what
test.
I do this as the pre-test.
Kick their
And
butt,
if
tell
they
them the
pass
test is
this,
going to be harder.
they're going to pass the state test.
Did you use this
Uh-huh.
exactly same thing? How did they do it?
The class average is a 72. So,
Oh, really?
yeah,
It's not bad.
not bad.
High school
But we
students guess well.
drilled on these for 2 weeks to get ready for it. And so they were drilled and drilled. This right here, that number 9, I don't think anybody got that one completely right. If I remember, they just didn't do something. They go, it's too many things to look at. and I probably had 12 that just didn't answer it. So that's where they dropped. But when they get down to some of these others, we use them quite a bit. But when they did this, then they did the state skills test, their scores were really good last year. So
you kind of scared them into, because I know Tech 2 takes you about 3/4 of the way up the mountain.
yeah.
And you need to go another quarter of the way to meet the requirements that we're asking you to do. Okay?
And just kind of so you know, we're kind of ahead on this a little bit because my Tech 2 kids compete in the UVU Derby, that Derby. So we have to make the car, it has to have a lid that opens and closes on it. And so they had to have their fits and tolerances done really good. So just in that project, we're really trying to.
So I'm going to turn the time over to Meg and Marnie to answer any questions and to kind of go through what their methodology is to teach the course, how they kind of have outlined what they are covering and how they are covering it, and maybe even some tips and tricks, that things that have worked and things that haven't worked so well. Because all of us educators, we all know it, sometimes it's a trial and error effort to get this stuff down. And this is not one of the most glorious subjects to teach, and so it can be very dry, very hard to teach. And I know Meg especially has tried really hard to spruce up this class and make it smell kind of good, even though students don't necessarily enjoy it. But it's so important. I'll tell you right now, students, what we tell them, if you want a job when you leave Weber State University and you do not have on your resume that you understand ANSI Y14.5 2009, you are going to be overshadowed by somebody who does have that on their resume. I can tell you right now, the hiring manager at ATK, every time he comes here to our advisory board meetings, he rails on this. Students need to be better at this. Students need to be better at this. And it's so important. And so if you can find an application for the students, they're going to be so much better at this. Instead of just the theory, have them apply it. Yes?
Well, when will we be able to log on to Canvas?
As soon as the CRN numbers are created, which is end of April-ish.
That's the mission process.
Yeah.
Really good. That's soon.
So if you want to limp along your syllabus for Beth's time restraints, I'm all right with that. So if you want to just copy my syllabus and say, hey, you're going to be doing it this way, you can do that. And then you can tweak it over the summer. I'm going to be honestly building these over the summer. So I'll send out a mass email saying, hey, I finished 1250 based on the notebook that I sent around. I'll send it to that email and I'll say, hey, I'm done with 1250. It's ready for you to look at. Any other questions?
I hope you mean 1160.
Yeah, I'm doing it for all the courses that are, all 6 courses that are available. Except for 2460, I'm not going to create a Canvas course for that.
And that's the one that also coincides with digital electronics.
No,
No, EDD.
it doesn't align with anything really. We are thinking it might align with
EDD.
EDD?
Yeah.
EDD.
That's what I meant. Yeah,
That,
DE.
the jury's still out on that one. I need to get the curriculum for that one so I can
It's
look
kind
at
of
it.
it's fun class. It's fun to teach because it's kind of got some reverse engineering to it. I like it.
Yeah, the teacher right next to me is teaching that. So this looks like a lot of fun.
All right, I'll turn the time over to Meg and Marnie.
My name's Meg. I didn't know anybody was going to use exactly this test because this test was infamous among students. They came to me and said that was brutal, Meg, and they hate me for it. This was the first final exam actually I created for students in to be honest, every semester I am making the material much easier and simpler. The very first time I taught this class, I was too, I don't know, if I was even over my head, I guess. I tried to put a lot of information into students' head, and then of course they exploded and it didn't work. So I'm cutting back, way back. So even, let's see, for example, this target symbol,
Yeah.
I just go through really briefly. Just tell them this is called a target symbol, and this means what, and this means that, and stuff like that. Then I'm gonna just go right back to the regular symbols and stuff, and I want them to have the basic understanding of what each symbol means, how to use it, where to use it, all those things. So let's see. I don't know, Marty, how do you do in your class?
So this is the first semester that I've ever taught it, and I just barely learned it over the winter break. And I watched Al Newman's videos on geometric tolerancing, which was a great, it's a little bit dry, and he's kind of hoping that on some of it I didn't stay awake. But I found that if you could give students visuals, okay, so she talked about datum targets and stuff like that, and I found these on his website. If you can find visuals that give them a visual idea of here's datum target lines and here's how they're applied and how you would inspect them and create them in inspection, that would help them because then they would at least get a visual on it. For the design engineers, that all they're doing is applying the symbols in their technical drawings, right? They have to understand what it means. But I think the manufacturing or is it the mechanical engineers, they need to know how it applies in real world situations because they're the ones inspecting it or creating it. Whereas for my design engineers, it's more how you stick it into the drawing and what it means, what each symbol means and stuff like that. It kind of crosses over both of them, but if you can give them a visual on it, then they're able to pick that up better. And I agree with Meg. I've tried to shove lots of information down their throats, and I'll have an assignment that I think will be fairly easy, and when I get it back, they failed on it completely because they didn't understand the concept. And with geometric tolerancing, the first 4 chapters of the book are the theory, and then all the rest of it is the same thing over and over again, and it becomes very dry. So if your students can get those first 4 chapters, they get that aha moment, and then they just apply it in with the specific symbol, whether it's positioning or symmetry or whatever it is. It's the same application, but you have to get them to get that aha moment before those, or you're going back and saying, okay, let's review material conditions or whatever it is.
Did you make these yourself?
I did not, but they can be. So this is Al Newman's, one of Al Newman's kits for his geometric tolerancing, and it costs about $700 for the kit, but I have a box about this big with different applications with like pins that go through holes, like a hinge type application, or circular holes that you tolerance or can position. You could make these very easily if you have access to, some kind of shop, because they're really rudimentary. They're supposed to look imperfect because we want to exaggerate the imperfections that we're trying to tolerance for. Even though we're calling out minute tolerancing, we exaggerate them so they can see really what it is that we're trying to do. And my favorite one and the hardest thing to grasp is the datums and the datum reference system. And again, this was another, just a visual on here's how a datum reference system would work and how a piece might fit into it and how it would wiggle around front and back and stuff like that, to get them to understand that this is what we're trying to control, is the sizes and features. And again, this was part of the kit.
Al Newman, I'm out of the loop on that, so you can find it on the website.
You can find it on the website, it's, if you just Google Al Newman or geometric dimensioning and Al Newman, He
Maybe we
has
can
his
pull it up
own,
over here.
yeah.
That's YouTube too.
And he has a number of videos that go through this, which is very beneficial. That's how I learned it, but they're very expensive. It's like $10,000 for a 16 video set. We actually had the VHS ones, and that's what I learned it off of. I had to borrow a VHS player, but I went through them, and again, he showed lots of examples, lots of those, so.
All right.
Am I spelling that wrong?
It's NEU, MANN. Gotcha.
GD&T.
Yeah.
Oh, yeah, it's German engineering all the way. It's,
Okay.
Yeah.
Is this it?
Yep, that's it.
Oh, I am German.
Is that expensive or is
uh-huh.
It is that expensive. We're in the wrong business as,
We'll record your lecture this summer.
is he that good? I mean, you say he's
He's
right.
thorough.
he is very thorough. Like I said, I learned it over 4 weeks, and I had no geometric dimensioning experience before.
Okay.
And that's the kit that I have right there.
So Alan, why don't you make these for everybody, will you?
And you could.
And you say that's the $700 kit.
Yeah.
Uh-huh.
Could you
Does
do
that
the
include that
assignment
plastic
GPS to
sheet?
make
Yeah,
these?
there it
Yeah,
is.
it does.
Yeah, because you can probably do them for $20.
Well, see, and even you could get something as simple as this to show extreme form variation and the perfect form boundary of PVC pipe and a twig. And just to show that example of that fit and how it can't violate that if you're talking surfaces. You have to get a little more creative when you're talking.
I can get a lot of
axes.
ideas from there. Anyway.
But you do. It's
Can you buy it separately? I mean, can you get the plastic, the wood blocks, I don't have a problem with that, the plastic would be a little tough.
You can just plexiglass. You just went down to Home Depot, you can buy a sheet of it for $4.
No, just make
Cut it on a table saw and put it together.
There's a place in Ogden called Precision Plastics.
Yeah.
That needs some polycarbonate for the VEC stuff we do. And you have to be able to prove that it is a certain thickness of polycarbonate. I got a 4x8 sheet of polycarbonate for $50.
That's not bad.
And it was like, I was getting 16.
That's the
inches
site
thick.
right there, huh?
Yeah, and it was anywhere else I looked was like, to have it shipped from Home Depot was like $150.
Okay.
Which was nice. The sign shops up there, it says.
Yeah.
It says
Well,
scrap.
Home Depot, for what I'm gonna do, Home Depot.
$3,000.
you just that.
So where did you learn on these at? Who had them?
Weaver State has the 1996 version, which is now outdated because it was the 94 update of the ANSI or the YNC, not YNCA, whatever that standard is.
All right.
And so I just watched those, and they compared the text that I had to what he presented, and didn't find a whole lot of things that weren't.
Would Weaver State be willing to streamline those?
I don't know.
Whereas
There
our-
is a
our-
copyright
our-
on it, and that's.
Streamline what?
Those videos that she watched?
There's a copyright on
VHS.
it, and I don't know what copyright laws.
If that's how expensive they
violate
are,
it.
there's gonna be some tight copyright.
Yeah, they're not.
What I was wondering if it would be available to us as adjunct faculty, just to sharpen up on and whatnot.
It might not.
To check out the
Yeah.
videos? I'm sure we could do that.
They're on VHS.
Yeah, it's just.
They are on VHS. I actually
Yeah, they still
recorded them
VHS.
and have them digitally. But like
You
I
didn't
said,
have them digitally
I
put onto
did.
DVDs?
See, like,
they're just, they're not even on DVDs.
with
right
our
now.
school
They're just-
district,
Yeah, which,
What do you teach?
Can they
We were high
borrow
school.
the VHS?
It is still, it's that expensive, there's gonna be some tight,
Yeah.
you're probably pushing the limit, where you have them on in-house, you might be lucky, but if we were to, you start mailing them to us, I
Yeah,
think
seeing
it'd
the-
be major.
that's, that, and
I
I
think-
don't.
yeah.
I think we could check them out to you.
I'm just saying what, you know, if we could look in to see what you could legally do,
tell me, can you find
you know? I mean, like,
I'll tell you what we can legally do, and that's nothing. Because if I ask the question, I guarantee they're gonna tell me no.
okay.
Because anytime I ask a legal question here, they always say no. So a lot of times, if Yeah.
So does that mean it's just better than the others?
Yeah.
Wait for you to do it.
That's why
Um,
Purdue and Purdue,
But yeah, I would say for your own personal use, we could check them out to you,
Okay.
like on a 2-week basis or something,
All
for you to
right.
review them. As far as making them available for your classes, probably not.
Well, they're gonna go way beyond what the classes are gonna learn.
Yeah.
But it gives you ideas of how to present something.
Yeah, I could see that point. For a student, it's just, if it's, that's what you're saying, a good
Well,
way to turn
here,
a kid
let's
off.
just watch this video and you'll see how easy it would be to fall
Never
asleep.
really comments in your
What's 5,000 apart, and that controls how much the surface could be tilted this way, how much it could be tilted this way. So that's the 5,000 perpendicular.
Oh, let's do that, let's do it all.
So if it has a perpendicularity of 5 on there, how flat is that surface then?
Well, if the surface has to fall on its own, then you get a flatness in there too, right?
Exactly, so perpendicularity also controls the flatness.
These the old
on it.
videos
You
or the
get
new
three
videos?
flatnesses
Those
in that
ones
also.
is a new.
Could you just put the flatness on there, or would you have to?
You might check like that.
Yeah.
You definitely need the perpendicularity, because you see how the flat is, you see how flat it is, you just be looking at this, it is a flat surface, but there's no relationship between the back.
So you got a film thing and it goes beep and you have
All
to
right,
go.
so now we've got
turn it.
A, and we got B, so since we added in B, we have to relate that back to A. Now we have the next one, C. Now C is only
yeah. Hang in there. It gets worse.
One of the things we've done in the district is, any teachers who wanted to take their VHS and their any CD, DVDs down to the district, they wouldn't give them back to you after they did this, but they streamlined. And I don't know what the legal rights or how they can do that, but they could, anybody in the school can now watch the videos that I took down to.
Certain publishers.
And I just was wondering if they did that, you know, if you guys could do anything like that, you know.
It's only on certain type, certain publishing groups.
Probably have to
Someone like
read
this,
closely.
like the ones we just got far to get, they can't do.
There's people out there that are experts at copyright, you know, would be able to tell you.
I asked about that.
Librarians always seem to be good at it.
I asked about that exact question because of videos that I'm showing, and the answer that I got was if you buy a specific license for that video, you can do that, and it's about 6 times the price of the regular video. So you're buying an electronic copy of the video.
Yeah, they have a video called The Flight of the Gosner. That's the same way you can buy it for $30. The Gosner Condor, you can buy it for $30 for a personal copy, and a regular copy's hundreds.
Yeah.
To get a school one that you can show at school, and
Yeah.
it's the same copy.
Yeah.
Yeah, you can't really understand what's going on.
Okay, move on this thing.
The first time.
So, Meg, do you have anything else that
Yes.
you would share with them?
Because we all know this is a dry, boring subject, I try to keep it my lecture minimum. I just teach 1 or 2 things in each lecture, and it takes 10, 20 minutes. And the rest of the class, I'm gonna have them do the exercise together. I'm gonna give them some handouts, some multi-views, and say, okay, let's add datum on the bottom surface. So that's datum A. Go ahead, do that. And I'm gonna have them do it and call some students up, okay, why don't you do it? Okay, that datum A, why don't we add flatness to it? How do you change that? You know, stuff like that. That kind of exercise together in class, I think that's helping, because I can walk around and see each person what he's doing, she's doing, and if they're doing totally wrong, I can directly say, no, that's not how it is. Remember this, that. And then some students are really willing to come up here and show what they know, and I'm gonna, you know, tell them exactly you're doing it right, and okay, how about we're gonna change this? What if you want to add perpendicularity to the left side surface? How are you gonna do it? How do you add the feature control frame and, you know, stuff like that? So I am doing more exercise in the classroom than just giving a lecture, because lecture is boring. Reading the book, some students said it's like reading a dictionary. it's just so boring to read the book. So I'll tell them, read the book first. Then if you're confused, just come to class and ask me questions, and we're going to clarify certain things, and we're going to practice so you know exactly what that is, you understand what it is, and you know how to use it on the drawing yourself. So that's what I'm doing. And last time I taught this class, instead of giving the test, I gave them a small project. I had them create their own robot, like a head and a body and arm and legs. So I told them, control each part exactly the way you want to control. For example, if your arm is going to be just a cylinder and you want to control the axis of the cylinder, how are you going to do it? If you have the sphere on the head, how you control it? You know, if you have just a box on your body, where do you want to add the flatness? Where do you want to add the perpendicularity? You know, stuff like that. That kind of project I gave them that last time, and I think students did pretty well, and I think they enjoyed it. Another thing is that students like to use SolidWorks. They actually want to create the part themselves and put it on the drawing. That's much easier for them to understand rather than doing by hand and stuff like that. So I try to give them SolidWorks assignments and the class exercise, minimum lecture, yeah.
About how long is your period, how long do you have them in the lab? When you do a lecture, is it, I mean,
15 minutes each class.
60?
50.
50.
And 3 times a week. Monday, Wednesday, Friday. Usually. That's my schedule.
Because I'm sitting in a school with a 90-minute period every other day. And I'm just trying to figure out if you've got this set up. It'll count, but I may have to do some.
You have to tweak it a little bit. It doesn't lay out the way it does up here at the university.
Okay.
So you have to kind of tweak it. So what I've done is the days I'm with them twice are lab days. The days I'm with them 3 times are lecture days. So I make them just drill notes down. And then the 2 days I have them just working on assignments, and I have a laptop and figure it out. So it's a little different tweak to it.
Okay.
But I have to run 2 of the schedules for different schools, so it's almost like it's what happens.
And I lecture the whole period, and I give them assignments that they go and apply the principles that we've talked about on. And they have assignments due every other week, whether it's a SolidWorks or a print reading, which I would recommend you have them do a print reading, telling you what the datums are and what the geometric tolerances that are called out. And then on the other weeks, I have quizzes that cover the chapters that we covered, and basic terms and terminology, and then some application of it, like the application of different produced sizes of the tolerances. And for my classes, the hang-up that they seemed to get was the difference between an internal and an external feature, and we spent so much time on that. So I would recommend that you make sure that they understand the differences between internal and external features, and how to apply those tolerances to such features. And once they got that, it just flew. It clicked, because then they could see, oh, well, I'm not talking about the largest diameter, I'm talking about the smallest diameter, depending on that, which one we're talking about. And then they could apply it to either one. I gave a quiz just last week where it was, we discussed the term for an internal feature, but had them apply it to an external feature, and they did swimming. They did great on transversing between the two. So I don't have any actual hands-on where I'm showing, not necessarily showing them the lectures incorporate that, but they are able to go and produce something and bring it back and show that they have an understanding of the application.
Well, and all my students get the SolidWorks software, so I give them homework all the time. There's just not time to do all stuff. My parents like them.
And parents like,
That's why I like SolidWorks better than,
What's that?
that's why I like SolidWorks better than, you use SolidWorks? I have to do
I'm sure we can still get it.
So
So do you guys have any questions? Marnie, what do you use to deliver your presentations? Do you use PowerPoint? Do you use?
I do PowerPoint, and I have, I basically just outline the text, each chapter, what I think is important, and we do cover most of the stuff, some of it more in depth, and then I do have examples that we do. I encourage them to do the chapter in the back of the book, because that's where I pull questions for my quizzes for, and it just, what is that word? What's the word I'm looking for? Reiterates the theories that we've discussed in class. The only drawback that I see in my class is I don't have any applications like Meg, where given a that they have to create a robot, because I'm not as familiar with it yet and haven't been able to apply it to real life things. I'm still working on the theory, but I'm looking into other texts and other applications that have more application to it. And I might just do some of the things that you've incorporated into your lectures. So that's where I'm going to go next if I teach it again, is have more application than just the theory.
So as you guys can see, we're also trying to figure out the best way to teach this stuff too. So any ideas or feedback that you're willing to give us would be great. I'm putting Marnie on the spot here, but would you be willing to share what you've created?
Oh, absolutely.
With these guys,
yeah.
As well as what Meg has done? Okay.
Yeah. And I brought just examples of quizzes and homework assignments and stuff like that they're hard copies, but I have digital if that would be better.
Yeah, if we could put it on Canvas, then they can print it, change it, however they want to do it. So.
I've got a question from my fellow teachers here. Are you teaching this for a year or a semester course? Semester. So 1 year course. 1 year. I've got.
If you do it a year, you'll lose the kids.
I'll be honest with you. It's challenging from what the feedback that I've heard from Meg. It's challenging to draw this out for 15 weeks.
Yeah, they just burn. I mean, if you can, that's why I do the project with the derby car, because then you can pour the hell out of them, and then they can be excited again.
If I've got it for a full year, and I'm doing numerous other things along with it, I can sprinkle it out over a year, and I don't have to. I mean, we can deal with it multiple times instead of just intensely.
Mm-hmm.
Maybe I could. I've got to keep enrollment too. That year course is hard enough
My
to
second
build.
semester, we did the 2460. And we applied a lot there because they're redesigning things to fit. So then they've got to apply because they're going to know how it works together. So I kind of need to cram it through there since they're ready for the next year.
I don't have the next one. That's the only one I have.
I wish I had 2 semesters a year long, because first semester I can just teach them basic uses of the GD&T, and second semester I'm going to have them design whatever they want to do and actually take them up to the shop and have them make it themselves, true to the print. They're the one who's going to make it. They're the one who's going to design it with the GD&T. They're going to the one who's going to manufacture it themselves, and they're going to inspect it, quality engineer thing. They can do everything themselves and understand, okay, that was a crappy design. It didn't work. They can learn that themselves. I think that's going to have them, that's going to help them understand way better.
Just as I'm getting into my 4th term here, this is, as I've gone through this year-long course, that 4th term becomes a term project. And what I have my kids do is they bring in a scooter, something from home, and then as a team they redesign it, but they each have to do at least 12 parts. But they have to design those and bring them together, and I'm thinking, okay, if I've done a good job through the year, now they're going to have to incorporate that and use it. I haven't hit it that hard. I hit it for about 3 weeks. The kids know what the structure is, how to set it up, and they understand real light theory, and they know how to fill out the form, but they really aren't. They don't know what it is. I mean, they've been introduced, and they know it exists. It's really about all they've got out of it. if I'm gonna have to hit it a lot harder than that, which I'm going to, I need to start really early in the year. I need to sprinkle it in. And then this final project of the year, you know, all right, Bionicle is one of those challenging ones that most kids, that's almost too challenging for those kids to do. But I've had them do some really phenomenal little projects. And they buy into it, it's their own, and they really pick it in.
If you're using the SolidWorks book that we use, at the back of it, it has Lego Mindstorm. And I don't know if your school is doing Lego Mindstorm, but that would be an awesome project to apply GD&T to,
They're
because
pushing that in the junior highs and elementaries, mostly the elementary schools. The Lego Mindstorm, the junior highs are pushing backs, and the high schools are pushing backs.
We used to be using Fisher Technique, but Fisher Technique is kind of being set aside. So anyway, okay. Well, so with having, I can still get it hammered, but there's no way I'm going to be able to teach it solid. I'll kill my class enrollment if I go straight in and do I do a 12-week or I do a term
a
and a
lot
half.
in the Tech 1 class, kind of introduced with simple things like tolerances, limits. We get that part introduced, then fits, then splinter seam, we get them then, and then I get the heavier stuff in Tech 2.
Okay.
And where I get into data points and stuff like that. Yeah, I kind of start a little early, so it's over a semester.
I can sprinkle some of the real basic stuff.
And I just haven't mentioned everything we do. I mean, I used to just do the model, print it off, do the model, but now I have some dimensions. So I can add
Have a
those
syllabus
things.
for your class?
I do have it. I can put it on campus as well.
Okay.
Do you have a hard copy? with you?
I can get that. I'll be right back.
Wanted to take one home. Thank you.
Thanks, Meg. Marnie, do you have any other comments or tips or tricks that you've noticed?
I don't, probably not.
So are you doing this in class, your model stuff?
These, I do. We talk about target points and target areas, and then I'll bring this in and say, okay, here's an application, here's what it would look like. You know, target area would be a dowel that you sit on, or a dowel that you bump it up to, or a pinpoint. I've also taken them up into the shop and showed them how to do and I'm still working on the terminology, the coordinate measuring machine, and showed them here's how we create the datum, these theoretical perfect areas that don't really exist. Here's how we create them with this machine and stuff like that, and show them some of the tools that they'll be using, the angle plate and the sign blocks and stuff like that, especially for the manufacturing. That's what they use. And then we have lively discussions on our manufacturer engineers will tell the design engineers, don't design it that way because we hate it. We hate how that ends up because it just causes us grief and trouble. And we talked about slots this week and how they don't like it when you call out slots at the center point or whatever. And so it's good to have both those because they get the feedback from each other and stuff like that. But I don't know if you guys have that particular diversity, but it is
I
good.
don't even know the difference between the two yet.
One just designs a perfect world, right?
Yeah.
One actually has to make it.
Yeah.
And we're the ones that thinks they are perfect, so, you got it.
There you go, see?
That's the whole purpose of this class, though, is to get that reality check for students that although it can be drawn on a piece of paper, it doesn't necessarily mean that it can be built, and that even further from that it can be inspected.
Well, we're doing a project like that right now where I had the commercial art students. They design salt and pepper shakers. They have twist tops on them, so you draw out threads. When we get those sketches from an artist and they try to put number to it, and then my kids try to figure out what the heck they're talking about, that opens the whole world of reality real quick.
So the commercial artist designs a concept and hand it to them, and they have to create it.
They have to create it and print it out in 3D and see if it works.
Or you can just use Project Lead the Way's models that they have to They have to measure them, and then you give them, because they're so messed up, you can't draw
I
apart
know.
from it.
Well, I changed my projects, like that little train. When we do the little train activity in there, my concept is, okay, because I hate, the thing I hate about the train is there's no engineering in it, it's the duplication. So I say, okay, you're gonna design this, the only thing you can't modify is the track, and these drawings are full of errors. You find them, you correct them, you're the engineer. So I finally threw my hands up trying to stay on top of those stupid mistakes and explain them.
And they tell them about their mistakes, and they don't change them.
No, they won't.
The laminated.
Yeah, so I changed the project. They have to modify it. It has to be modified. And I tell you what, I got some fun looking cars coming out the other end. But I'm no longer in the project Lead the Way project. It's all about being creative and that.
And
So
which
those cars,
project
they
Lead the
come-
Way is that?
Huh?
Is that IED?
Yeah, the IED course. And so they come in. One of the projects they have them is they have to design this simple little toy engine. They have to build this toy engine. Well, the instructions on the toy engine are just laced with errors, and some of them, the zeros are in front of the, they're just laced with errors. So just turn around and say, you got to modify it. There are errors in this. This is done by your boss, who definitely wasn't paying attention to what he's doing.
Yeah.
But you got to solve the problems. And it's totally solved. I just don't deal with it anymore.
It's so important. And if I could just put a plug for this class, by the time they're a senior in our program, we force them to do a senior project where they come up with their own design idea. And we can really quickly know who did well in GD&T and who did not do well in GD&T, because they rise to the surface so fast. The first semester, we require them to document the project, meaning they completely design it. And if they are doing multiple, so if they have manufacturing engineers on their team, they have to build their prototype in the first semester as well. And then in the second semester, then is when they get into the manufacturing or the producing multiple instances of it. And boy, do they realize at that moment they have that aha, holy cow, I put 2 10,000ths of a tolerance on this part and I can't make it, and inspect it and keep that. And we always ask them, why did you hold such a tight tolerance? I don't know, that's what it was in our book. So they don't make that connection even in our program until they're a senior, when they actually see their own design failing inspection because they've held their tolerances just too tight and they don't understand even that concept. So what we really would like from you guys is teach all of the concepts, get the application in there as much as possible, but realize we understand that they're going to come up here still unprepared to do this. GD&T is something that has to be applied multiple times before you actually really get it. And the more that they can go and inspect parts, which these models are phenomenal, the more they understand and can accept that their parts may look perfect on a piece of paper, but by the time you give it to a machinist and he machines it and he tries to inspect that, it's so important that communication is going both ways. And that's really what we want them to get across and understand, is that GD&T is very, very important. And to be employable, you've got to understand it and be able to apply it. Are you going to be perfect at it? No way. But you've got to be able to apply it. So you've got to have print reading skills, and you've got to have application skills. So to apply it to something more than just a block with a hole drilled through it. A real live part, and understand why.
Walk us through your grading on the robot project. How do you look for the amount of tolerance you're allowing for your fits? What are you looking for on those? Do they make the parts and so they actually fit physically, or?
We don't have time to make that. So I told them the tolerance, how much tolerance you apply. Before that, I explained the tighter tolerance, it's harder to control, it's going to cost more, and it's, stuff, so on and so forth, and it's a functional tolerance and stuff like that. So I told the students, think about your part. How important is it to you? Is it important? Because this feature is important because it's going to insert somewhere else, like shaft or something. Then you have to really think about how much tolerance you want to apply. But profile, it doesn't have to be that big, tolerance doesn't have to be so tight. Because circle could be square if it's not that important. So I was not very critical when it comes to the tolerance number, value, but I just told them, think how much you want to apply, how tightly you want to control, stuff like that. So when I was grading the term project, yes, the number was way off, like why would you want to put this much number or stuff like that, but I didn't take off that kind of points from there. What I was looking for is, are they applying datums correctly? Because you have to apply datums up and down movement, left, right, 6 degrees of freedom. And sometimes students do apply datum only on the up and down, everywhere up and down, and that's wrong. They're not understanding the concept. So those are the things I was looking at to grade.
And this is a great application of that degrees of freedom. You can see I can still spin it this way and move it this way and this way, but it stopped that way. And this was one of the ones where we saw aha moments that, if I just do 2, I can still go this way, but I'm no longer spinning or anything like that. And when I do it 3, it's fixed. And you have to give them, we're looking for fixed because we're going to be inspecting the part in somewhere else and making it somewhere else, and you've got to have the same reference frame to get the part interchangeable per, manufactured, whatever it is. So the visuals are good. And they were able to get that concept where it's a hard concept to.
Was that kit you got right there part of the kit we saw on the internet
It's
just while
the
ago?
exact kit.
So it's the 700, you said 700?
Yeah, it's 700, it's 2009, so it's the current kit.
Yeah. I don't know how $700 is a lot of money, but it should be nice not to have to go make it.
Well, you get your inspection instrument with that $700 as well.
Yeah, it comes
The little, yeah.
meter and
Yeah.
it has calipers, so you can do inspections and stuff like that.
Well, I have a set of calipers on every one of my computers, and that's been really good. My kids, by the time, it doesn't take them long before the first thing they reach for whenever we do a lot of this reproducing. Hand them a tool, hand them something, they have to reproduce, and they're constantly using the digital. I bought digital calipers with a dial, but
See, I can't find dial calipers anywhere except for Harbor Freight.
They're cheap and they work good.
They're cheap and they work good, and I never have to worry about batteries, and the student actually has to think about the number instead of just read it. And you
and I've got, but I can get metric with the digital. That's what I wanted is metric. And they couldn't with the tile. And I don't know that matters, but
well, it's nice. It's nice because when I happen to have my students do a lot of Lego designs, and Lego designs, you can go online and you can find everything in metric. You can't find it. You have to have the.
yeah, that goes, the online stuff's all metric. I don't know. I don't know whether that's wrong or not, but my kids are constantly measuring. The fact that they're not using a dial, but they are constantly measuring.
Yeah.
Which is important.
It is.
Really important.
I feel so far.
Well, any other questions,
You don't even-
concerns? Nothing like getting
This
paid.
is a semester class at the university here, right?
Yes.
Yep.
Typically, we suggest that they follow it up the semester after they take 1060.
Uh-huh.
So they would take, in your case, Tech 1, and then the very next semester take Tech 2. Tech 1.
I guess I'm confused as to what we're doing in the state, because I was thinking it was a semester class, then I went and told everybody in my high school is, no, it's a year class, and now you're saying it's a semester class?
It's a year class.
It's a year class.
But we can offer, or I'm offering, a different college course each semester, because the way the objectives.
No, we can do that.
That's just a loophole in the state's lack of care.
That's how, I was just sitting there thinking that's how I'd have to handle that.
Well, I think the state will let you run it either way. They're gonna suggest a year class. But I
think what they told our district.
My register
that you could only
lady
take
will
a
kill me
year-long
if I go
test.
back and tell her a different story
So
again.
if you run as a semester, you're
So
done.
let me diagram this for you. This is how
Tech one's a semester.
Tom's doing it, right?
Yep.
So he's taking,
Tom's the standard.
And I did lose 2 for the GD&T. They kind of
he's taking Tech 2, which is a full year course.
Yep.
In the first course, he's teaching 1160. In the second part of the course, he's teaching 2460. That is available. I should turn that. I'm gonna have to repeat that now, because Tim needs to hear that. Is he watching right now? No. So, Tech 2 is mandated by the state to be a year-long course. So the way, what we're asking is if you can get enough GD&T in 1160, then they have to apply that GD&T in 2460 to do it's not even a reverse engineering project. It's kind of like a reverse engineering project, but it's kind of like improving in a design.
So we're supposed to be teaching this technical design 2 as a full year class?
Yeah.
If your school is allowing you to teach this one semester,
Keep your mouth shut.
keep your mouth shut and just do it.
I told them it was one semester and they never questioned it, so I'll just be quiet.
Keep your mouth shut.
Dave said it was 2 semesters.
You're saying they will only give you the test at the end of the year? Well, I've never asked them, so.
Just keep your mouth shut.
I'm teaching it for a year, I'm not teaching it.
See, and what you really should be doing then is doing both.
Because that gives you 6 college credits, which makes mommy and daddy extremely happy if you're an instructor, and your kids stay with us.
And if they take, so they're taking Tech 1 from you or IED. Are you
Yes,
teaching IED?
I teach both Tech 1 and IED on 2 different days.
Okay.
IED is 1060, right?
IED is 1060.
Right.
DOE is MT 1000 or something?
POE is a different division there.
And then, if they were a mechanical engineering technology student or a manufacturing engineering technology student, and so coming from Tom's 2 schools right now, they're done with design classes at Weber State University. They are only going to learn the theory here. They are done. Now, of course, the design engineering students will continue on with more design courses. But for manufacturing and mechanical, they're done because they're required to take 1060, 1160, and 2460. Those are the only 3 design courses.
And 2460 is a
Application of GD&T.
GD&T, and they've got to get it right, because if they're not paying attention to the book takes them from a real life model down to toy model and back up to real life. So they got to kind of think what sizes have. They really they can twist it.
That book is going to be available for you to purchase through just the Copy Center.
The one you guys, this book right here?
No,
the 2460.
That's the 2460. That's next week's training. Glenn West is the one who put that book together. So
it's thick.
yeah,
It's got a lot of
it's
resources.
got a lot of information.
A lot of information. It's a lot of information.
So, any other questions? Concerns?
What are the things you've seen that students lack that we may need to hit more of? You see anything that's coming through that we should maybe do better? Or?
I'd say tolerancing, and then I would say true position. If there's one thing, I'm sorry to speak for you guys, if there's one thing that industry uses the very most, it's true position on bolt patterns. It's so important that they understand that concept. Like Meg alluded to, you've got 50 symbols, but you probably really only are going to be applying 10 of those 50 symbols
on a daily basis. And those are gonna be things like cylindricity, concentricity, and true position.
Can you say those 5 times fast?
No, I'm sure I
Be
can't.
careful.
I couldn't even say it one time. But those are the kind of things, like, when I was a tool designer at ATK, those were the ones that I applied on a daily basis. And of course, maximum and least material conditions, understanding those. How about you in industry? What did you see?
Flatness, tradition, and profile of surface.
When you say surface profile, you're talking about parallel, perpendicular?
No, because we're dealing with a really complicated surface, so you can't really define.
Oh, you're talking about, okay,
Mhm.
profile of a line,
Yeah.
profile of a,
Yeah.
okay.
I can tell you a real live example. I worked on the Joint Strike Fighter, the JSF, and we had a 40-foot one-piece. They changed the design after we couldn't do it, but we had a 40-foot wide mold. It was 15 feet deep, and it was the entire fuselage, the bottom fuselage of the Joint Strike Fighter. And we had to have a surface condition of 5. Over 45 feet. It was almost impossible to hold. We did it, but that mold cost $1.3 million. And then they scrapped it and went to a 3-piece wing design because they weren't satisfied. Well, we, of course, at ATK charged them a lot of money, right? To hold that flatness over 45 feet to 5-10,000 below. So they went to a 3-piece wing design and they riveted it together. So yeah, our government wastes a little bit of money on that project.
But yeah, now we can afford things.
Yeah.
I wish we could take students to a local, company somewhere, like tour thing, and have them show some actual piece, how they are manufacturing and how they are controlling and stuff like that. Otherwise, they don't see an actual part, how it's being created, made, and manufactured or inspected. They're not going to understand because their visualization ability, I'm sorry,
Well, these kids don't make go-karts anymore.
No, they only do
Everything they do, yeah, they're very good with thumb
They're
dexterity.
very good with SolidWorks because that's how their brains have been grown up. They're good with their hands, their hand-eye coordination. They can do this all day long. But where you take that to the next level, I'm saying the 3D model. They can create the 3D model pretty good.
Yeah.
But when they have to put that 3D model on a 2D print and then dimension that print, that's when it kind of gets sketchy.
Dimensioning is where the whole thing, it's where kids struggle. There's got to be a better way to teach it than I'm teaching it, but I keep working on it. The dimensioning is where I frustrate my kids. Our kids have great time, clear up, and they're loving what they're doing up until I say, all right, we're now going to create drawings, and you're going to dimension them. And I review that, and all of a sudden, kids that were just cruising just shut down. I'll start losing kids. I start having
What
kids.
prints do you have in review? Where do you get your prints from?
In the back of the book.
Just the good old back.
But they have a number of ones, and there's print reading exercises where it says, if you go to this print, find all the data and describe those data. So the front face is the back face. It makes them visualize it. Because that's what I've noticed with my students is they cannot visualize it. They're like, well, it's just that face. Well, what face is that on that print? And they can't orient it. And then it says, okay, now find all the form tolerances. And they have to go through and find the form tolerances. Now tell them what it means. And so I've appreciated those applications because they have to do the thinking in it.
I can tell you firsthand, my dad works at JBT Aerospace. It used to be called FMC. He's one of their engineers out there. We go to lunch. Luckily, I get to go to my lunch with my dad at least once a week. It's not uncommon that he brings a print to me on Wednesdays and says, me how do I apply this GD&T? And it's, I probably shouldn't have just said that on tape, because they're proprietary things. But, I mean, they're fighting over how to apply the GD&T. And although we're trying to teach them something that's very technical, there is still a lot of subjectiveness to it, and how it's applied, and how you're forcing people. The one thing that I tell my students when I used to teach 1060 is, all right, you've designed a part. Now you tell me if it's a good part or not. There's a huge difference between a part and a good part. Is it going to work if I have to put something else with it? So creating assemblies and living in a world that is not perfect, like SolidWorks, where I turn the crank a little bit too far in the machining on the drill press, I'm done. I just lost a part. So one of the things that whenever I advise a student for this class, I always tell them that they should be taking 1210 at the same time. And 1210 is a machining class. And boy, does that make a huge difference. If they can visualize, print, making a part, along with applying tolerances and GD&T to it, wow, it's pretty powerful. So if there's classes at your high school where, like a machining class, that you could tell them to take at the same time, that would be great. You're being a machinist, teacher.
I do that SIMS class, which is integrated manufacturing.
Oh, okay.
Where we build a lot of stuff on that.
You'd have to work with Mock.
On the
Yeah, we don't have any manual stuff.
You have to take a boat over his island now.
Yeah, they program.
Or we use EdgeCam.
It still has to mount up to another part though, so that other part better be dialed in perfectly too. So, and in order to program it correctly, you've got to dimension it correctly. So,
I had a kid make an iPod cover. Thought it was so wonderful. He's on his fourth one.
because it doesn't fit.
I tell him, you gotta measure, you gotta get all the dimensions down. Now he's got 4 of them. Now he's making 6 more. But he finally got it right, and all his friends want them.
Yeah.
We're doing it on a 3D printer.
Oh, okay. I was gonna say, now can he repeat what he did?
Yeah,
that would be the hard thing.
We get those printed out in solid.
All right. Well, nothing like getting paid for 2.5 hours and coming for an hour. So, if there's no other questions, I will be the collector of the resources from everybody, and I'll put them out there on Canvas. And as long as you've signed the roll thing, then we're good to go. Take some food with you.
So, sorry for
Now, did you early
are we getting a little
descriptive geometry?
You don't need descriptive geometry anymore.
I know.
Best place to do that is on the manual drafting board.
Yeah, can you send me the STL?
Yeah, we've moved away completely from manual drafting
And so
because it's not being done in the
how
industry.
much it's gonna cost. I've got something.
Well, the fact is it's just not a part of industry anymore.
Nope.
No more part of industry than the slide rule is.
Not an
Descriptive geometry has been taken care of in SolidWorks.
I sent him back instructions for how.
Well, I
create a 3D model.
I have a section in the old textbook that has a bunch of gaskets.
I'm not letting them.
And I force them to use geometry tolerance, and that's my descriptive.
Hey, do this for me.
They have
I'm
to
just
do-
gonna roll over
They have
and
to
do
do
it.
tangents, and they have to do all these different geometric tolerances.
So-
They have to learn how
He
to.
gets them
That-
to
that's
STL, sends them back to
probably-
me, says.
I'm not talking
"We're
about
not sure how much money you
construction, I'm talking about geometric, descriptive geometry.
Half
Descriptive
scale,
geometry,
quarter
yeah.
scale.
See, there's really no need for it now that you've got a 3D model.
But they do need to know how to apply their, they don't use any constraints, peel back off. Oh, that's an old, they gotta release it, they gotta 3D print it. They need to know that's okay.
See, in
We do
SolidWorks,
everything half.
what I teach my students,
So we're gonna do that,
until your part is
like
black,
salt pepper shakers, we
meaning
come
it
in
is
half,
fully
we make a
constrained,
snap joint.
Yeah,
and
well,
stuff.
You're not good.
dinner is, as long as it's green,
That's great.
it's gotta go blue.
Yeah, that's.
Until that sketch is blue, if there's green on it, you have problems.
Exactly. Exactly,
Because
that's
if
perfect.
you push and shove it around,
So-
you can put, and that one section on gaskets, as they start doing that, it becomes obvious because they're tweaking this and tweaking that, trying to get things in place, and they tangent this line, all of a sudden this part over here shifted on them. And so they have to undo that, then they come back and they lock that down, then they go back and tangent this one, so this part. And so they find that you're doing the tangent, you're doing the coincident, you're doing the collinear, making these two lines collinear, all these geometric.
Yeah, that's great.
As they're doing that, because they have to keep that thing locked down. And then when I come in, when I check it, and they can bring up their sketch and I flip on those symbols, and I'm looking to see if they padlock to it. Okay, it's all blue, where's the padlock? No padlocks. And a couple times I catch it, oh, look at all the padlocks you got here. Well, it's the only way I can get it to go blue. So, yeah.
That's a great transition. If you can get them to visualize those geometric constraints, just tie those into an actual GD&T, and you're good to go.
Well, that's what I'm saying. I can see already, like, and then change my Tech 1. The first thing we're going to have them do now is they do this, we do baseline dimension. So I'm going to start having to put data on our baseline. Here's the data profile, and this is your data. Now do your baseline. So everything's going to have a data reference. And okay, look, you're pulling a dimension off, but it's not connected to components. You know, we're doing baseline dimension. So if they're trying to dimension and their dimensions are coming off something, oh, here's your 3 data. You know,
You can teach the design intent right there from the very beginning. What am I trying to forecast that I'm going to need to be able to modify or change easily later on?
Yeah.
And you can teach that as well too.
Yeah.
Design intent.
I can see where that can go.
Like if you're working on symmetry, later on we want